Hello everyone, welcome to my new video. Okay, आज म चाहिँ अहिले यहाँनिर UPCT को ल्याबमा भनौँ, यो चाहिँ मेरो डेली वर्किङ रुम हो। यहीँनिर बसेर म काम गरिरहेको हुन्छु र यो भिडियोमा चाहिँ मैले तपाईहरुलाई यो UPCT मा रहेका हाइड्रोलिक ल्याबहरू, यहाँनिर दुईटा छ मेजर ल्याब चाहिँ, एउटा चाहिँ उता इन्टरनेसनल बिल्डिङमा छ र एउटा चाहिँ यही डिपार्टमेन्ट अफ माइनिङ एन्ड सिभिल इन्जिनियरिङ अन्तर्गत यहीँ रहेको छ। र यो ल्याबहरूको बारेमा चाहिँ तपाईहरुलाई के कस्तो छ र नेपालको भन्दा के छ यहाँको फरक हाइड्रोलिक ल्याबहरू विथ माई प्रोफेसर एज वेल म देखाउने छु तपाईहरुलाई। र सुरुमा चाहिँ म तपाईहरुलाई यो जानेर म बसेर डेली काम गर्छु यहाँनिर देखाउँदैछु। यहाँनिर डिफ्रेन्ट टाइपको हाई प्रोसेसिङ कम्प्युटरहरू छ है। यहाँनिर तपाईहरुले यसलाई चाहिँ तपाईको ल्यापटपमा कनेक्ट गरेर अनि तपाईहरुले घरमै बसेर पनि चलाउन मिल्छ यो कम्प्युटरहरू चाहिँ। यहाँ बोर्डहरू पनि छ हैन, यदि तपाईहरुले केही प्र्याक्टिसहरू गर्नु पर्यो भने। र यहाँनिर प्रिन्टरहरू भयो। ओके, अनि रुमहरू पनि एकदम ल्याबहरू ओइल छ, एसीहरू, लाइटहरू एकदम सबै कुराहरू राम्रो छ है। अनि त्यसपछि पढ्नको लागि मेटेरियलहरू पनि छ। ओके, एन्ड सो मेनी पिपल क्यान वर्क एट द सेम टाइम। यहाँनिर चेयरहरू थुप्रै छ, सबैजना बसेर कामहरू पनि गर्न मिल्छ। र यहाँनिर तपाईहरुले 3D प्रिन्टर पनि देख्न सक्नुहुन्छ है। यहाँनिर 3D अब्जेक्टहरू पनि प्रिन्ट गराएको छ, यस्तो सेपहरू 3D प्रिन्टर। यहाँनिर ट्र्यापिजोइडल सेप पनि यहाँ प्रिन्ट छ है। यो कुराहरू यहाँ छ, यो कम्प्युटरहरू पनि टन्नै छ। यो चाहिँ म यहाँ बसेर काम गर्ने ल्याब भयो। र अरू अब ल्याब भनौँ अथवा यो रुम भयो। अब अरू मेजर ल्याबहरू चाहिँ म तपाईहरुलाई देखाउने छु।
Now we are moving towards the first lab, which is located at the international office of the UPCT. So let's watch what is inside the lab.
We have two different labs. We are going to visit. The first one is more related for classes, for laboratory practice. Okay, this one. This.
Slide. Yeah.
Right. This is the. We have two different channels. This one that has 12.5 meter length and 30 centimeters of wide.
Yeah.
Right
This
now,
is just open channel.
open channel. This is a labyrinth ware that we are trying to analyze to know how it's working.
Yeah.
Here we have another lab, another flow, another channel, a smaller one than this.
And there is no water inside here. Yeah, you say you already
right
said.
now we remove the water to the right.
I think this lab is now under construction.
No, this not. It's the other. Here you have several non-linear waves.
Yeah.
This is a labyrinth. This is a piano key wire.
Yeah.
And that we test here. And there you have other models. This is a sediment trap. So we can sediment.
Yeah.
Sand. So we can recirculate water and also sand.
Oh.
So we here in this part.
What is this?
This is the
Collector?
Yeah, this is the final. This is the reservoir to maintain the water, and this is the filter for the sand.
Oh.
If the sand is not trapped by the sediment trap, it's finished here in this filter.
Oh.
Okay, and here we have different parts.
Oh, wait.
OGs,
OG, yeah.
crested weight. This is a Venturi. Here we have. This is for the smaller one, and here we have broad crested wave, radial
Yeah.
gate.
Yeah, gate.
Yeah.
Radial gate. Yeah.
Yeah, this is a plain, a vertical gate, piers with different shapes. Here we have different shapes and different types. Here we have.
And
Here we have.
nobody is working here inside in lab.
Right now, no. Right now.
This is
Here we have several of these with hydraulic jumps.
yeah,
With ski jump,
bucket.
partial flumes, different waves.
Yeah. Okay. Thank you. And
Those are also for the water, to maintain the water. They have all reservoir. This is a laser
yeah.
to measure with high speed cameras
Oh.
to obtain the flow velocities of the particle of the water.
Oh, it is joined to the computer. Yeah.
Yeah.
Yeah. It gives data directly to the computer.
Yeah. Now you can obtain like this image. You can obtain the velocity figure, the velocity distribution of the. Here you have the arrows indicating the velocity of the fluid.
Oh.
Okay. Those are several studies we have performed in the last years with some universities, with the ministry. This is a study of a dam in Ecuador. This is another model that we
Yes.
have in the.
Here is water.
This is a robotic location system for our probes that we are developing to be more easy to obtain the data instead of using only the point gate
Yeah.
to have something more automatic.
Yeah. This is one lab and there is another lab also. Yeah.
Yeah.
Okay.
Okay. Let's go to.
After watching the first lab, we move toward the second lab of UPCT. So let's watch what is inside lab. Okay.
Okay.
Oh. Let's. So let's move one by one.
Yeah. Okay. This is a tank.
Yeah.
Also for water, but we are not using right now.
Yeah.
We have another tank in the reservoir for all the water.
Oh.
So here, you can see we are changing. We are here. We have the pumps, the different pumps. We have 3 different submerged pumps
Oh.
to send the water by the pipe to the different models. This is a new channel that we are building. Okay.
Yeah.
The new one here.
And inside here, any turbine?
We have in Alfonso 13 we have a turbine.
What?
Turbine,
Oh.
but a Pelton turbine. Those are connector for pressure sensor or piezometers.
Yeah.
Okay. This is another
Open channel flow.
another flow. In this case, to analyze bottom intake systems, bottom racks. To collect water,
Yeah.
the idea is to collect the maximum amount of water with the racks, and all the sediment continuing in the river. So this is the channel for water collected,
Yeah.
and the sediment, the sand, the gravels continuing in the river. Okay, and this is
And-
sand because we are testing with sand and different materials.
Yeah, and what we can find out from this experiment? What?
Here we are analyzing the clogging phenomenon.
Yeah, yeah.
If to try to have the
Clogging means clogging inside pipe or
clogging is when you have, we can see there in the racks.
okay. Let's go.
You can see the rack. This is a system, a device that we perform to. We are designing probes to measure the amount of air that we have in the hydraulic structure in a hydraulic jump, in a falling jet, or something like that. And this is a device to calibrate those probes that we are designing. Take care here.
Okay, okay.
For instance, those are bottom racks. Okay?
Oh, racks, racks.
Racks.
Yeah.
That we can put on the bottom of the river.
Yeah, yeah.
But if we have sediment transport, this profile, this circular profile, is going to collect a lot of water. But the problem is that if we have gravels, gravel are going to be clogged.
Yeah, yeah.
So until it arrives to an equilibrium, and we want to analyze the equilibrium. Yeah. This is more efficient to collect only water than this, but this is more efficient when we have the sediment.
Yeah.
Because here it's more difficult to trap the gravels.
Yeah.
And we want to know, for depending of the basin, depending of the terrain that we have in the river, which is better.
Yeah.
Okay? And this is a model. This is a shark crest whale.
Oh,
That
can
one.
I go?
Yeah, yeah. Take care, please. This is a shark crest whale. This model right now is in the lower part, but we can put until here, move from this part until this level to increase the filing distance. Okay, and we are measuring the behavior of the nape of the rectangular jet.
Yeah.
We are measuring the velocity in different profiles, in different cross sections.
Yeah.
We are measuring
just
the
check.
take care.
Okay. Oh.
Okay.
Yeah.
So we are measuring all the fall.
Yeah.
Measuring the air entrainment, how the air is entering into the water, and how it's dissipating energy depending on the specific flow that we have.
Yeah.
And later, when the water arrives to the plunge pole, to the bottom, it arrives with a certain energy. We are measuring the energy with different pressure sensors.
Yeah.
That are the holes that we have there, and we can match the energy that the water has to scour or to erode with the behavior of the rock or the material that we have in the bottom of the plunge pole. If the energy of the jet is higher than the resistance of the material, it's going to be a scour. If not, it's going to maintain without a scope. And here we can have a direct impact, having here a supercritical flow, or using different water levels, water cushions, and it depends on the water cushion, the behavior of the here, it changes totally. Okay. Okay? It's a pity that we don't have water right now with the civil works.
And this is just for to circulate water,
Yeah. We are going to change the pump.
What is this? Is ventilation?
Ventilation.
Yeah.
We have here.
And this.
This is the channel for the collecting water. It's in supercritical. With the idea is the rack but if some material, sand or gravel overpass the rock, it's not in this channel. It arrives to this deposit in where it's sediment. This is a sedimentation tank or deposit.
Okay. So this also reservoir.
Yeah.
Yeah.
So maybe, I don't know, in 1 month it's going to be working again. Right now it's a bit.
Mostly here open channel flow instruments are most of here, and also other any instrument for pipe flow analysis.
Pipes, we have a pipe system in where we analyze what happens when we have a mixture of air and water in a pipe, and we have few models, but for the classes, not for the research. In the campus, in the other campus. Yeah. That we can see next week. I can show you. Yeah.
He will be arrived in the process of in 5-10 minutes. So he's collecting.
Okay. We are not of the for practice and also a museum.
Energy.
Water engineering. So this is not as huge as the other that you saw.
Yeah.
This is more for kids, for knowing how.
Let's introduce one by one and what it means, what we can find there from it.
A model to explain what is the need of having a dam, with, in this case, with a morning glory. This is an embankment dam, where we have the spillway. We have here another dam that allows us to intake to collect water for water potabilization plant with drinkable water. Here we have a small model of this is a turbine, to create energy. Flow meters, historical flow meters. In our case, we have different.
And what we can measure from this?
This is the flow meters to measure the water, to control the water.
Yeah.
This is a bank to create different project, different practice. Here we have different. Those are also flow meters with different methods.
Yeah.
This is a new one. This is a bulb. This model is for water hammer to check what happens when you close the bulb quickly.
There piezometer are fitted. Yeah.
Okay. Those are for sensors, and we also have piezometer. We can work with all of it. This is the typical for energy loss in pipes. Yeah. Considering different materials, what happened with the
we connect different pipes.
Yeah, with the here and here with the manometer.
Yeah.
To check what is the energy loss.
Here, this is only one lab or another also?
No, here we only have this one, and the other is what you know.
Yeah.
And this is a model, a small model of a harbor.
Harbor. Yeah.
A port.
Yeah.
In where we can design the dikes.
There is water.
This or this one. Oh, we can consider dikes or vertical walls or with different material, with different rocks.
And
this is a model to analyze what happens when we have raining in a street. So it's a raining model
And here, through this, there is infiltration.
Yeah.
Oh.
And here we have the different gates
Oh. This one.
to collect the water.
These are street inlets.
Yeah.
Oh. And the water falls from here.
Yeah.
Then-
The water comes from here, from
Yeah.
those.
Yeah.
Here is break
Yeah.
to have drops, more or less.
And, where we collect the water and finally we measure discharge.
Right now it's not mounted, but here we have a reservoir, a small tank,
Yeah.
and from here we pump all the water.
Oh.
Okay. And this is a small system, more advanced flow meters with different characteristics to check how a house is working. Here is closed. Let me check if I have TV.
Okay. So this is the hydraulic lab. Okay. Oh, this
A ski jump,
yeah.
a concrete way. This is an arc dam.
Arc dam.
Yeah. This is a lowering way. Different ideas.
Yeah.
Let me check if I can find this video. It's from now.
En este taller haremos que los niños jueguen.
This is me some years ago.
Right.
Okay, and in this case we have the same that you have done in your project, but in this case with augmented reality. Okay, and where we can modify the terrain, obtain the elevation from a 3D sensor, and reproduce what the effect of the water. This, let me check. I think that I have.
This is your own YouTube channel?
Yeah, this is from the university.
Oh.
This is from the university channel, and I think that we have a better one. This is the same. This one. I think that this is complete. Hi.
Sorry, I'm late.
Oh, don't worry. This is the model that we have in that room. That
You don't have key today, so
no,
it
but
was in fun.
but this is the idea. This is sun, in where we can project the image, a sensor that record all the elevation.
Yeah.
We can modify the terrain. We can check. This is a mountain. This is a lake.
Yeah.
Okay. And later, when we have the topography that we want to.
And what we will find from this model?
This model?
Yeah.
This is the software is open source from the university in US, and you can obtain all the information from the website. Here you can have this one. This was a bit small problem, but you can see the water flowing as you did in your project.
Here some children are.
Yeah, this was one of the first tests that we carried out,
Yeah.
and later.
That's okay.
But it's
Now that's all about our lab here.
no.
So this model is prepared by the students.
This is for more fun than for students, for kids, for learning what is the hydraulic, what are the behavior. Let me see.
See the turbine. Is pen stuck. This is pen.
This is the model. The same model that we have. Okay, with the same idea. And you have the river.
This is the actual model what we made in the grass.
Is similar. This is for visual purpose.
Yeah.
But the idea is the same. It's for flooding situation.
What is this flood? This is real water?
No.
No.
This is all calculated. In a moment in which you can calculate the model. It's the same. Shallow water equation, 2D models. This is quite simplified to be calculated in real time and with a computer, with a small computer. This is not valid for hydraulic, okay, but for learn how the process works, it's really nice.
Yeah.
Oh, the terrain is created by putting the sands.
Yeah. You can change the topography, you can move the sand,
Yeah,
you
you
can
just change the terrain and the water
Yeah.
flows from here to the
Yeah.
Nice.
And it's the same that in Harras, the water moves by the gravity, and you can move from one part to another.
Wow.
Here is a lake because it's in a lower position, but later if you move, the water needs to readapt to the new condition. Okay? For instance, there. Okay?
Okay.
It's a pity that I don't have the key.
Okay, no problem. And this lab is
This
used
is-
now or not?
This we are preparing
Oh.
for being a museum, and also to do some practice like that in that model, the water hammer, and some other practice that we have in a small models. And here with this panel from this potabilization plant, we are creating a big model.
Yeah.
Yeah. To have here with a tablet and a QR
Yeah.
can follow and visit the plant. With the different steps, the filter part.
This is for potable water.
This is
For-
potabilization.
What it means?
Potabilization?
Yeah.
Drinkable water.
Oh, yeah, potable. We say potable water.
Yeah.
Yeah. So using different filters, we make the water pure.
Yeah.
We have to filter sea water or
Yeah. We also we have several plants
yeah.
to collect seawater and to
And in Cartagena, what is the major source of water, either from sea or from river or any natural?
from both. Depending on the month,
Yeah.
we have more from the river and more from the sea.
Yeah, I don't saw too many river here. There are
No.
many dry river.
No, we have many dry river and not so much.
Yeah.
So and we have a lot of farms
Yeah.
that collect
Okay.
We have a lot of agricultural engineering in the surrounding.
Yeah.
We need a lot of water, but we don't have water, so we need to have a lot of dams, a lot of channels to connect them,
Yeah.
and we need to use a lot of water from the sea.
Okay. That's all. Thank you so much.
Yeah. I need sorry, but I have another meeting.
Yeah. Okay. Let's go outside.
We have a small gift for the token of love. A cock with a flag of Nepal.
Oh.
It's a gift for you.
Oh, thank you very much. Thank you. Could you take a photo, please?
Yeah. Sure. Give me one.
Oh, really nice. Thank you. Thank you very much. It's really nice.
And it's a flag of Nepal.
Yeah.
Yeah. Okay.
I saw in your emails.
Ah, yeah. Yeah.